Hi folks, so this is question 6. So first part A, it just asks us to do the circumcenter of a triangle. So it's nice and easy. If you remember what circumcenter is, it's easy enough. You just have to be okay with using your compass. So what you need to do is you need to find the perpendicular bisectors of two of the lines, and then it's wherever they meet. So you must show constructions though, obviously, so it says that, so you have to measure it out properly and do it the right way. So this is the way you do it. I won't do it, but I'll just explain how. So you're going to put the pin of your compass on one of the points. Doesn't matter which one really you start off on, but if you just put it there and then extend out your pencil out kind of across the line. So you just need to extend out your pencil more than halfway and then draw a kind of an arc. So you can draw kind of a full arc like that, or you can split it up into two little arcs. But you're going to do exactly the same then on the other side. So you put the pin of your compass here now and you extend out your pencil, and then you'll get something like that. You'll draw a full arc again, and then the perpendicular bisector of that line, you need to use a ruler and just draw it through the middle like that. So this mightn't be very accurate, but that's how you do it anyway. So that's how you do a perpendicular bisector of that line. So that part and that part should be the same, should be equal if you do it correctly. Then you're going to do the same thing with another line. So if you put your pin of your compass, so if we do this line here next, then do the perpendicular bisector of that line, you're going to put the pin of your compass there on the same point as before. Extend out your pencil more than halfway, draw an arc. So you might get something like that, and then do the same, put the pin of your compass there and extend out your pencil more than halfway, and you should get something like that. And then the perpendicular bisector will be through those points. You just have to draw it through those two points where the arcs meet, so there and there, and you can extend it on. So what I'm getting here then, this is very inaccurate because I'm just using rough hand, but my circumcenter would be there. Okay, that would be my circumcenter. You can do the other side then, so you can do this side here as well and do the same thing, just extend out the pencil more than halfway, do two arcs and join it up, and you should get it to meet then at the same point. So it should be kind of something like that, maybe afterwards. But you only need two of them really to get all the marks. So that's how you do the circumcenter. Right, so for part B then, you've just got to fill in bits of whatever you know. So you've got to start filling in angles. The first thing you can fill in, because that line comes from the end of the diameter and then that one also does, okay, so that means that angle here has to be a right angle. So if they both come from the ends of the diameter, that's a circle theorem, then that has to be a right angle there. So that's 90 degrees. Now that doesn't include the extra little bit, that doesn't include this bit here. But we know that much is 90 degrees. So if you look at the angle or the triangle ADB, okay, or ABD, okay, it tells us in the question that that's isosceles, so that's important. So that there is isosceles, because if it's isosceles, then AD has to be, the side AD has to be equal to the side DB. So those two sides have to be the same length, and then these two angles down here, this one and the big one here, okay, the 40 and the whatever little bit is in there, have to both be the same. Alright, so it's important. So the angles DAB, angle DAB has to be equal to DBA. Because the triangle is isosceles. So you know that the top angle there is 90, we've worked that out. So if you do 180, take away 90, and then that's 90, and then divide it by 2, that'll give us what both of those angles are. So that's 45. So both of those angles have to be 45. Now you know already here that up to that much of it is 40, so the extra little bit in here then has to be 5. And we know that this has to be 45 then as well. Next bit, we're looking for ADC. Yeah, so ultimately we're looking for this kind of big angle here, so the 90 plus the little bit extra. So the next part is that this angle in here, we actually know what this angle is then. So the angle ACD, that has to be 45 as well. So the reason is because it's another circle theorem. It's because both of those angles are formed from the same arc. They're formed from that arc around here, from the point A and the point D. So you've got that line and that line, okay, and then you've got that line and that line. So they make this, they have to make the same angle then. So that's a circle theorem. So that's 45. So if you just look at the triangle ADC then, just the top triangle basically, if I was to draw it out roughly again, you've got that the top part is what you're trying to find out. That's 90 and plus the little bit extra. This down here is 40, and then this down here is 45. So we know that 45, 40 and 45, and then we just need to find the other side. So all you have to do is do 180, take away 40, take away 45. And then final answer will be 95. So a tricky little bit of a question that, so you need to know those two circle theorems. So the first one that if the two lines come from a diameter and touch the circumference of a circle, they have to make a 90-degree angle. That was the first thing you needed to know. And then this other one, that if 2 points on an arc make 2 different angles on the opposite side, then they have to be the same. So those two have to both be 45. Okay. Right, so part C then is a proof, and it's a tricky enough little proof. We're going to end up proving it by contradiction. So let's put in some of the things we know anyway. So we know that O is the circumcenter. So if you think back to the part A of the question, that's kind of the same. It asks you what? It asks you to actually draw the circumcenter, I think, yeah. So remember how we drew the circumcenter then. You have to find the perpendicular bisectors of each line and put it in the middle. So let's just assume that our circumcenter, we'll just go kind of central there. Let's just assume our circumcenter is kind of there. So therefore, that there, that's probably not very accurate. Yeah. So therefore, that side and that side have to be the same. Now this is very rough. Down here then, that and that have to be the same. And then if you were to draw the perpendicular bisector of the line PR, okay, so that line and that line have to be the same. And each of them then will all make right angles. Because they're the perpendicular bisectors. Also then, this point in the middle, so the distance from P to this point would have to be the same as from, well, it's the point O really, it's the circumcenter. It has to be, so those two black lines, they have to be the same. And then that, so they're, because they're all radiuses of the circle. Now then, so it's going to get a little bit messy then. So let's just look at the triangle, so the POR, so we're looking at this triangle here. So if you think about that triangle for a second, and I'll just rub it out so it doesn't make it unnecessarily messy. So the distance from P to the middle and R to the middle have to be exactly the same. Therefore, that has to be an isosceles triangle, and you're actually going to get 3 isosceles triangles. So it's the three triangles with black lines basically. So if you're thinking about what this angle is here, it has to be exactly the same as that angle there. So let's just call that angle kind of 1. Alright, so just labeling it 1 because it has to be, they have to be the same. Equally then, this angle here and this angle down here, they have to be the same as well. So let's call them 2. And then this angle here and this angle here have to be both 3. So I'm just labeling that. So each angle at the base of the 3 isosceles triangles have to be the same. Then we've got the angles in the middle. Now I know it's looking a little bit messy here then, but if you were to think about any isosceles triangle, basically we've dropped the perpendicular from each of them. So you would think about that line there, that's just gone from the top of the isosceles triangle down to the middle. So if you were to draw any line straight down the middle, that angle would have to be equal to that angle. Those two would have to be the same. So therefore we know, so it's going to be the same then within our circle here. So I've labelled angles 1, 2 and 3 already. So I'm going to label this one 4 and this one down here 4, and then we'll label this one 5 and this one 5, and then label this one 6 and this one 6. So it's just that the two angles beside each other have to be the same because it's just splitting the isosceles triangle. So I know it's getting a little bit messier the whole time now, but we should be finished kind of labeling that part then. Right, so we're going to assume then, so we're going to end up proving by contradiction. So I'm going to assume O is inside. So it's inside the triangle PQR. Alright, now let's look at the big triangle then. So the triangle PQR. So let's just, well, the sides of that have to all add up to 880 degrees, don't they? So the angle at P plus the angle at Q plus the angle at R have to be equal to 180 degrees because it's a triangle. Let's kind of break down angle P there. So look at the angle P. The angle P is contains angle 1 and angle 3. So I'm going to break that. So angle 1 plus angle 3. The angle at Q is angle 2 and angle 3 as I've labelled them. And the one at I'm getting confused for myself. Yeah, so the one at angle R then is the angles 1 and the angle 2 added together. So plus angle 1 plus angle 2. So all of those added together have to be equal to 180 degrees. And we're going to get a contradiction then down here. So I can change. So I've got two angle 1s there in that, so I can do 2 times angle 1. And this looks a little bit complicated now, I know. Plus 2 times angle 2 because there's 2 angle 2s. So 2 times angle 2 plus 3 times angle 3. Sorry, plus 2 times angle 3 as well. Don't know where I got the 3 from. So plus 2 times angle 3 equals 180 degrees. I'm just putting the angle 1s and the angle 2s and the angle 3s together. Right. That's an equation then. So just think about it as an equation. So I'm just going to divide across by 2. So I'll divide everything by 2. So I'll get angle 1 plus angle 2 plus angle 3 has to be equal to, divide 180 in 2, you get 90 degrees. So angle 1 plus angle 2 plus angle 3 have to be equal to 90 degrees. Let's just move 2 of them over to the other side. So angle 1 has to be equal to 90 degrees, take away angle 2 plus angle 3. Right, so this is where we get our contradiction from then. If you look back up here, in order for this thing to be true, for that O cannot be inside PQR, well, in this sentence here, this is the important thing, that has to be true. So the angle at R has to be is greater than 90 degrees. So they use R here, but that has to be the same then for Q, so, and for P as well. So that has to be greater than 90 degrees. And the other one here, maybe not those two actually, but definitely the one at R, that has to be. So if I go down here, you'll see that 1 plus 2, they're saying that 1, so the angles 1 and 2 added together have to be greater than 90. Okay, I'll delete that line because it probably wasn't the best one to use. I can change this around then so that angle 3 has to be equal to 90. So I'm doing the same thing really, but I'm just changing the angles. Minus 1 plus 2. Angle 1 plus angle 2. But angle 1 plus angle 2 can't be greater than 90 based on this, because 90 minus angle 1 plus angle 2. So this is saying that angle 1 plus angle 2 has to be less than, that's a less than sign, 90. So angle 1 plus angle 2 is less than 90. That's what my equation has said, but up here it says that the angle at R, which is the same thing, is greater than 90, so it can't be greater than 90. So it can't be greater than 90. So it can't be greater than 90 because of that equation that I got down at the end. So a tricky question that, but that's it, that's everything done.